Hello everyone, this is Bradley. Today this is a tutorial that people requested for a very long time. It took me a while only because I was busy for my project. Also, I would like to improve the workflow to make it easier and so on. So anyway, let's start. So here we're in Blender. As always, I'm going to use the presets which you can download for free from the link in the description. The main purpose today is to introduce you a concept of aligned surface tangent. And this is a little bit tricky because I'm not the author of these presets. It's actually introduced in Blender conference last year. And fortunately, the license was CC0. So I just took that and modified that and so on and so forth. Okay. I talked about the surface tangent concept in the past when we are trying to orient this instance on the face. So the major issue of traditional align Euler to vector in which we can align this rotation to normal is that right now we are asking this empty to look at top with its z-axis, for example, but you can duplicate an instance and orient it differently, and this instance is still looking at the top, but its orientation is different. That's why just the one axis locking is not enough, that you need to actually lock the other axis. Okay, so this is the same when you are trying to work with a mesh or other things, that you do not only need a normal, you also need a surface tangent. So in the tutorial in the past, I made a tangent using the topology nodes, corner of face, face of corner, and so on. It's a kind of very complicated thing, but it's kind of very accurate because it's based on the actual topology of your geometry and you have lots of control with it. Today, however, we are going to use a very weird concept. This is based on a weird formula that I do not really understand. So if you do not want to use the presets, you can just copy this node setup. But as I said, I just copy and paste this setup from Blender conference. So whether you would like to use the preset or not, I'm not going to explain anything because I do not understand anything from this setup. Okay. It's okay if you do not understand anything from this setup because I do not understand anything as well. But you need to make sure how to work with it. So we are going to do a test because you can take a node from the internet, but I don't actually know if this is working correctly. So we are going to test that. The way we are going to test that is basically the same as we are going to align Euler to vector with this surface tangent. So we are going to use a 3D viewer. So this is my preset, and by default, it's really just a marker. Unfortunately, I cannot really color that because of the limitation in geometrynodes. But anyway, so if you normally plug the geometry into it, it will tell you the position of the attribute and the rotation along with the normal. But anyway, today we are going to use this align rotation to vector to look at our surface tangent. Let's scale that down a little bit. And we are going to look at the actual x-axis. So if you go to advanced setting, there's a drop down that you can select the d-axis of it. So right now you can actually see how this tangent is actually oriented. It's very interesting because I don't actually understand how this actually works, why it works so well without dependence on the topology. It's purely based on the normal, actually. That's also why sometimes there's some inaccuracy. But at least even in Suzanne head, it's working very well. So basically, if you put a vector looking downwards, you will have all this kind of orientation looking at downwards as well. And it's kind of, it works like a charm on this surface. And basically, this is it. Okay. There are some other settings such as this factor for this aligned surface tangent. You do not need to worry about that, and I may change and modify them or even remove this section in the future. Right now, you only need to understand that by inputting a vector and doing math with the normal, we're generating this secondary axis, which we call that the surface tangent. I do not know how surface tangent is generated in Cinema 4D particles, but this experiment of particle emission is basically inspired by Cinema 4D. So here, let's start with a simulation zone. We are going to join geometry with our final particles. And let's take a simulation zone. And I updated the workflow. In the past, we have to join geometry for our particles and set particle parameters for whatever stuff. But right now, I combined them together into a join particle node. Okay, so we're emitting particles. We need a particle emission. So we take a point distribute so that we can decide the amount of emission instead of using the density of distribute points on face, which is uncertain amount of whatever stuff. Okay, so we emit particles. So now we can see the particles is setting on the Suzanne head, but there's no velocity if you play this animation. So let's increase the time frame of this whatever, and let's plug this normal into the velocity. And I also want to remind you that this velocity already multiplied with the delta time, okay, as you see here, so that you do not need to put additional link to whatever stuff, okay. And it's not really working because we recorded the velocity, but we didn't output that into the set position. So we put this velocity into the offset. You can see this particle is being emitted, but every time this particle is being spawned at the same location, so we take a time frame for the seed, and then this is what we're looking at. Okay, these particles are emitted along with the normal. This kind of setup by itself is already kind of interesting if you combine with that, you combine the noise 3D or noise turbulence. As you can see from other variances of this animation. But today's topic is talking about aligned surface tangent, so we are not going to talk about this one. Okay. The principle, however, is really the same. You just it's based on which kind of velocity you input to set a position. If you now directly plug this surface tangent into the offset, you will find that they are not moving because there's no normal for these points. This is just like many other cases where you try to use the matched points, then you find that the normal is not working. So the solution is that you basically need to capture an attribute or store an attribute before you convert everything into a point. For example, you have a normal here. Actually, you put a normal here and it doesn't work still. Actually, why this doesn't work? I don't know the reason, but anyway, the thing I'm going to change is that I'm going to really sample this surface tangent every frame because my particle is going to move. So every time the location of it on the surface will be changed. So you want to change that. So now if you look at this setup, this particle is just moving downwards in a very fast rate. This is simply because we don't have a delta time, or this value is too large. So we're going to scale that. You can plug a delta time here, but it's very likely you need to further modify or multiply with some other values. So I'm going to use the value precision, and there's an on delta time option to multiply this value precision by itself. So now if I look at this setup, you can see this particle is being generated and they are moving downwards with this surface tangent. Okay, and you can see this leaking outside the surface at this extreme point. It feels like our Suzanne is tearing. It's kind of very fun, but anyway. So this is the basic result where we put our surface tangent into our particles. And to make this animation more interesting, we basically just try to add variances of this aligned vector. So instead of making everything just looking downwards, I'm going to put a noise 3D and plug that to aligned surface tangent. So now you can see these particles is moving at different directions. Some of them is looking upper right, some of them is looking to the left upper, and so on. You can see these points are being converged to different locations as well. And you can increase the frequencies to make it interesting and so on. What's more important is that you can evolve this tangent as well based on the time info node. And you can basically just try. And here I'm just going to increase the factor so that these particles will move faster, so that you can just see that it's moving a little bit too jagged. So let's decrease the rate a little bit. Okay, so basically this is the idea. This looks kind of very weird, but this is really how I did. The rest is about the parameters and the settings. For example, you can change the seed for different particles or generations. For every generation, you can put a different noise. It's actually not use the time frame because it only makes the noise changing seed completely from frame to frame. What I'm going to do is I'm going to use and name the attribute called time. It's already being generated, as you can see. This is actually the birth date of our particles, which is being stored in these joint particles. And basically this is it. And you can try to increase the rate so that it looks whatever stuff. Looks kind of crazy. And we increase the amount of particles generations. You can see it becomes a little bit more interesting and so on. Okay. And the rest is really about tweakings and so on. You can also add some noise. As I mentioned earlier, we can go with noise 3D or noise turbulence. You can just add them and evolve them and with the seed and so on. There's nothing special other than that actually. It is possible you can make these particles to really sticking on the surface, because right now if you play this animation, at the end of the day these particles will just move away from the surface because of overshoot or other reasons. So to make particles sticking on the surface, you can try with the geometry proximity so that these particles can really stick with the sampled position onto this surface. But this also makes it a little bit boring. Anyway, I'm not going to do this today. What I'm going to do, however, is actually to delete these particles after they are being too old. You know that I already recorded a birth time or their birth date. So if they are older than 25 frames, then they will be killed. This is actually very important because otherwise you will have trillions of particles in Blender. Unfortunately, Blender is working on CPU for geometry nodes. So if you have trillions of particles, it will be very slow to operate. You want to delete particles. I already confirmed that with actual frame rates in geometry nodes. So, yes, this time fourth is basically using the time to calculate a particle age. And based on this duration, you are generating a fourth from 0 to 1. And if everything equals to 1, then you are going to delete that. So now you can see this. There are some particles which is trying to get out. For example, this particle is trying to get out, but they are being deleted over time. And to make the process more natural, we're going to scale these particles. So we can set a particle. We set point radius, and we take this fourth. We can take a float curve So we start with a tiny scale, and we pick the scale, and we kill the scale or radius, whatever you call it, and we remap 0 to 1. So we need to make a tiny particles. So let's take a value precision. So this is 1 divided by 10, 0.1. And we just decrease that further. So now we have this setup. Okay. It may not be very obvious, but if you try to render that or something like that, you actually see that this particles is actually being disappeared on the edges. It actually looks kind of cool. And we take a subdivision. Let's make it looks nicer. And the people asked me how to smooth all this type of mesh. It's kind of very simple, just say smooth. And it does not shade smooth the points, but it does not cause any issues despite a warning. If you want to remove this warning, you just set shade smooth only for geometry. But actually, this is basically it. Okay. So there's actually nothing really special or difficult. This is a pretty simple setup, but the rest is really about adding parameters and so on. Okay. And if you want to render better motion blur or to make it work in eevee, you want to make that into an actual instance. So anyway, let's set a material. We take an emission material. You will see that this particle is not being shown. This is only for eevee, but if you switch to cycle or eevee next, you can render point cloud. But as I mentioned in my motion blur tutorial, sometimes the motion blur does not really working as expected for some reason, which I do not really understand. So in order to potentially resolve this issue, you probably want to instance some point. And it does not need to be some complicated geometry. Just try to even use a simple grid. And we can take a radius into scale. We can also align rotation to velocity. So this is actually really just align order to align rotation to vector, and we plug a named attribute velocity into it. But in this particular case, we do not have a velocity, so we need to record a velocity. Or you actually just store a named attribute for our velocity. Then you can solve the same problem. But anyway, we are inside the simulation zone. So we just keep everything as it is. And now if you play this animation, with this align to velocity, you can see these particles are being oriented, whatever. Okay. You may want to orient it with 90 degree. I forgot the actual axis for it to look correctly, but anyway. So, and then you can plug you can enable the motion blur or whatever. It will take a lot of time to actually work, but looks kind of okay. It just takes a lot of time to render sometimes. Okay, so these are the things that you can potentially try. Just to know that you must not realize the instance for motion blur, as I have discussed in my motion blur tutorial recently. At the end, I want to talk a little bit about the color changes of these particles based on its ages. Right now, everything is just white throughout, but we can take the shader editor and looking at what we are generating. You can construct a fold based on the time. So you can take an attribute and times time or other things. But I want to synchronize the settings between geometry nodes and the shader, and I do not want to use the driver, like copy as a new driver and so on. So the thing I'm going to do, it's not really ideal, but I'm just going to store name attribute to store that as a fourth. So F, so that I can directly read this F. And I'm going to color ramp it. And now you can see the color changes. If their age is too young, then they are going to be black. So I'm going to change that into red color. And at the end of their lifetime, they can be kind of blue color. So now if I play this animation, it may not be very obvious. Oh, one thing I forgot to mention. Yeah. We are working with instances. So it's not a geometry, it's instance. So now you can see there is a mixture of red and blue. And yeah, basically just try to tweak all these kind of values, whatever. Then you get whatever stuff. Let's increase the strength, let's increase the bloom. And sometimes you may want to change the color management based on the Ajax or Filmic, whatever stuff. It seems Ajax looks kind of nice in this case. We can make the word color really black, so it becomes really shining out. And then the rest is just about taking another material, make it fully black, so that Suzanne head is covering the back face of it. Anyway, so basically this is kind of idea. We can definitely go more advanced case where we are generating traces on Suzanne's head, below, and whatever. But that's not the point of today's tutorial. I just want to make sure you understand this simple setup. It's not really difficult, but there are many things and the parameters that you can potentially tweak to make it more interesting or even worse as well. So I hope you enjoyed this video. I'll probably see you next time. Bye bye.